Hey guys, it's Vince. Today I want to discuss a solution to a problem that's been plaguing a lot of guys who are fabricating their own chassis and trying to do it right by using a professional substrate like aluminum or steel. And they get to that tricky part where they have to mount the steppers to the chassis and they realize they have to square up the holes to their chassis. That's really tedious, especially, even if you have the right tools, it can be quite tedious because you have that center shaft of the stepper. And again, you have a lot of measuring to do, squaring things up. It just is tedious. So what I decided to do is figure out a way to eliminate a lot of the headache of having to find a machine shop or having, drill presses and other tools. I wanted to figure out a way you could do it with hand tools and get very accurate results. So what I came up with is a template system. Again, I'm going to just cover the basics. I do graphics on the side, so I decided to create and formulate a scale template to a Nema 23 chassis stepper. And what I did was, by utilizing vinyl, I can die cut these to scale. So these would actually peel off, mountable right directly to your chassis. My recommendation is on how you would do it is, of course, you're going to square up, make a square line using either T-square or carpenter's square. You want to make sure it's very accurate. And then you're going to make a vertical line. And then you would just simply use the square edges of this, and that'll tell you exactly where your motors are going to mount. Now, the best way to utilize these, again, you know that the holes are all fully scaled properly. The center hole you see before you is at 6.35 mil to symbolize the center shaft of the stepper. Now, my shafts are all 6.35 mil. If you require these in a different size stepper shaft, you can let me know. I can make these at will to basically support any guy that wants to mount his steppers to his chassis in the easiest format. And believe me, this is probably the easiest you're going to get. If your chassis is clean of oil, you simply stick these there, use your center punch. You've got, again, your cross hash marks right here. All you have to do is make the marks on each of these. Then I would start by either hand drilling very slowly so you make a nice divot. A lot of guys like to go in and start drilling immediately after they center punch. I don't. I like actually going in with the drill, a sharp drill, slowly starting to make a divot even wider so that you know your drill won't slip, especially for professional machining like this where you really want it to be as close as possible. Take your time, start it off by hand. Once you get that actual divot in the actual aluminum or substrate you're working with, then you just step up into the drilling platform. You can use a hand drill then, of course use a lubricant, and go right through it. Very simple. This is a very easy process. The holes are scaled accurately to my steppers. If you're using someone else's steppers, you can message me, and once again you give me the dimensions and I'll scale it properly for you, and then this way you're set to go. These crosshash lines I just put in here to give you an idea of how to actually use the system. They will not come with the crosshash lines. And again, the center punch, I'm just putting that in here to let you guys see exactly what I'm talking about. If you guys are not familiar with a pressurized center punch, it's your best friend. It's the best $4 you'll probably spend at Harbor Freight. It works exceptionally well for this, and I promise you the accuracy is very good. The big thing here is doing it slow, taking your time, and once again utilizing the tools you have. If you have a nice sharp set of drills, you will not have any problems with this. It's very easy to do. And my recommendation, a lot of guys, I've seen guys do straight through holes. I personally like on my mounts to actually be tapped on the actual chassis end. So wherever you're screwing your motors onto, you definitely want that other end to be tapped. And then what I like doing is on the opposite end with the standoffs of whichever mounting platform you're using, I don't like that to be tapped, because then you can adjust the motor slightly to and from when you're using a flexible coupler. And again, guys, please don't use those cheap Chinese aluminum accordion couplers. They're just garbage. They're just not really designed for accuracy that you're looking for. If you want zero backlash, get yourself a good set of couplers. They're not cheap. I know they're about 20, 25 a piece. I mean, a good set of couplers, remember, any motion is going to be transpired directly to the mechanics, which will be reflected in your work. So again, we're looking at precision. Do yourself a favor, get a good set of helical. There's a couple different brands out there that you can go with. I like Helical myself. They work exceptionally well. Bellows makes some as well. You really just want a flexible zero backlash coupler. And why we want flexible is that if this motor needs to be adjusted slightly because of misalignment, which again is normal, you're going to have some misalignment. You're never going to get that dead center. It'll always be off a couple thousandths here, a couple thousandths there. The big thing is you want it as close as possible, and the coupler will self-adjust to the shaft so it does not put stress on your motor, and you'll be good to go. But once again, using these templates it's the easiest system I've seen. I mean, the beauty of it is, of course, that they're self-adhesive, so as long as your chassis is free of oil, of course, you'd wipe down your aluminum with some acetone or either alcohol or acetone. I prefer acetone. Put them on. You're set to go. Use your squaring line, square them up right where they're going to go. Drill your four corners out, and you're set. Just move to the next one. You have perfect templates then to mount all of your motors. And again, even the center shaft is there. If you need to find out the center mark, that's there. I mean, you could actually fabricate if you wanted to, even with hand tools, really, using your standoffs as well. I mean, this is pretty easy to do if you're making a standoff system in a big block of aluminum, or I've seen guys use plastic. I don't recommend it, but you could use virtually any substrate you want and utilize the templates and go with it. If you wanted to have a permanent template, you could also take this and apply it, of course, to a solid substrate like wood. Wood would be a perfect template for this. Just put it over maybe some hardwood, 3/16 thick, and just apply this, sand it flat. You could do that with hand tools with a piece of glass. You could sand it flat on each edge to give you a square line, and then you would just go on there and you'd be set to go as far as actually reusing the template over and over again if you wanted to do marks. So once again, they have a lot of uses, and the beauty of the whole system is you don't need to use any fancy tools. It'll save you a trip to the machine shop. So overall, great investment, super easy to use, and for the guy who's building a machine himself, they're priceless. Once again, this is Nema 23. I can make Nema 34. I can make Nema 17. If you have a specific motor's dimensions you want done, I can scale them for you direct and make them custom. If you need more information on them, I can make more information. If you want less information, I can make less information. Overall, it's pretty much customizable in any format. But the beauty of it is, again, the simplicity. Machine shops, they're going to hit you hard. Typically, to get motor mounts drilled in any type of aluminum substrate, you're looking at about 90 bucks an hour. So I'm just telling you now, be prepared for that. And that's why a lot of guys message me is, there's got to be an easy way to do this. And, templates, a lot of guys are using templates, but they're a pain to hold in place, and then you got to square them up. I'm using a Graphtec cutter, which I can tell you right now, the accuracy on these will be 1,000 to 2,000ths off as far as this actual scale piece. So when you take this actual square out, it's going to be dialed right in to that location as far as being square. So once you square it up with lines on your machine, you're pretty much set just like that motor is sitting there, and then you would naturally just drill out the holes and you'll be good. So again, we're using a CNC to utilize making templates for you to make your CNC. Think about it that way. It's the same principle. Overall, works perfect. If you guys have any questions, now once again, this is a 300-ounce template, which is Nema 23. I also got the 600-ounce templates. The only difference is these are Nema 24. Now, my motors at Nema 24 600-ounce are the exact same mounting dimensions of a Nema 23. So they're always listed as Nema 23. The difference is the dimensions of the exterior frame. This dimension on the exterior frame is 4 mils different than this dimension. Okay, and the main reason that is because this is a much beefier motor. I mean, we've got a lot more torque here. We're doubling the torque. So other than that, the mounting platform of the screws, exactly the same. But I scaled everything accordingly, so you literally have a box which is the same scale of the real motor. So mounting now becomes a complete joke. You can mount this on any substrate you want, preferably, again, I prefer the professional ones, aluminum or steel, and you guys will be good to go mounting your motors with basically machine shop precision. I mean, if you're doing it right, and once again, you're tapping on your machine's end, on the actual chassis end, you're tapping those holes, and you use yourself some nice standoffs. I prefer stainless. Again, those are what I use in my store for that reason. Stainless does not give. It's just a very true substrate. If you're using that and they have some slight play, you cannot ask for better, because it'll let the motor self-adjust then to that flexible coupler for slight imperfections in alignment, and that's really what you're looking at with your transmission. So just keep in mind, and again, overall, process, very, very simple. If you have any questions, message me. But for those guys out there who are going at it themselves and, you know, the true engineering type that's out there and wants to do it and do the best job that they can, I can't think of a better solution than this. I mean, like I said, I use this in the same principle I've used in professional manufacturing. It works excellent, especially when you're using accurate equipment. Again, I'm using a Graphtec, which again is one of the best names in the industry as far as graphics. So I can tell you the accuracy in scale will be dialed right in. Once again, my name is Vince. If you have any questions, contact me through eDealers Direct. And again, these are fully scalable, so if you need more or less, I can build them to order for whatever you need. If you need a template for a breakout board, you got dimensions, I can do that as well. It'll speed up your process. You certainly then can do this in your house yourself if you have the proper tools. So just keep that in mind. Thank you again. Take care.